Understand how the ice slides over the mud and the rock. It really sets how fast they flow, and how fast they flow is the thing that's going to set future sea level rise.
The Erect Glacier Initiative has provided funding to scientists here in Wisconsin who are studying those interactions between ice and the bed it sits on. Lake Michigan was carved out tens of thousands of years ago by an enormous glacier called the Lake Michigan Lobe.
And lots of sediment was deposited out of the middle of the lake. But when the glacier re-advanced later, it carried it to the sides and deposited it in these till units that have a very fine composition, just like the sediments you might find underneath glaciers in Antarctica. Then we can go around to places like this and gather till that we can use in our experiments.
Those experiments take place here at the University of Wisconsin in Madison.
When you look at the bottom of fast-moving glaciers, the ice is often at something called the pressure melting temperature. And what that means is that the ice is right at the point where it would melt, making that ice-bed interface really important for controlling how fast the glacier will move. The problem is that that interesting spot that we want to study is below 2 kilometers of an ice sheet. So rather than having to go to an ice sheet and drill all the way through it, we can do those sorts of things in the lab, and importantly, we can do them in a controlled environment.
This is the machine that makes it possible, a ring shear device.
This is a giant machine that basically takes a donut or a ring shape of ice and presses it against some substrate that we would use to simulate what's at the bottom of a glacier. We actually spin the ice at the same rate a glacier moves. We put the pressures on it that you would find at the bottom of a glacier. We put sediment in the bottom. It's just sediments that we've taken from actual glaciers. It means that what we're doing in there is very representative of what you might find at the actual ice bed interface of a glacier.
It's not going to be warm.
So basically this works by using a hydraulic press that applies the pressure to the base of this instrument, and it's frozen into the teeth right there that allows us to grip the ice and spin it. As it's shearing, that shearing action causes it to melt.
So I understand there's a bit of setup involved with getting this experiment off the ground. Do you mind if we watch you assemble it?
Yeah, absolutely.
The setup involves a lot of manual labour for poor Natasha. She's using this hydraulic jack to line up the teeth with the water that will be frozen around them.
It's a very tight fit. So now we will drop the temperature in the freezer to about